Hello students, in our previous class we have studied about different types of lenses and few terms related to lenses like pole, focus, focal length, center of curvature, optical center as well as aperture. Using those terms, today we will study about formation of images, how images are formed using lenses. Yes, I told you in the beginning class only, when we use or when we wear spectacles, okay, if you look at a person, his image will fall on your retina. Before that, the light rays coming from a person will refract at your spectacles, If you people are wearing one spectacle and you are looking at a person, the light rays coming from the person will undergo refraction. These refracted rays through your eyes will reach retina. Okay. See students, the size as well as nature of image of an object. This is object, its image will form at retina. The size of the person as well as nature of this person, like real image, virtual image, okay, will be different. That we will study in this class. Okay, if person is very near, what will happen? The size of the image will be different. If person is far away, the size and nature of the image will be different. These things we will study in this class, that is image formation by lenses. Okay. First, we will take formation of image by convex lens. Using convex lens. Here we have few cases. At the beginning, I will take if object is at infinity. If object is at infinity, yes, I have taken one convex lens. Okay, suppose the object is at infinity. This is optical center. Okay, and one object is at infinity. Object is at infinity. Yes, this is optical center, this is focus 1, this is focus 2. Yes, these are the light rays coming from object which is at infinity. Yes, one more light ray, this is also coming from the object which is at infinity. What will happen when these light rays strikes the lens, means meets the lens? See, one optical medium to another optical medium, they will undergo refraction. After refraction, they pass through focus. Yes. Now we will write properties related to image formation. Yes, okay. Position of the object is at infinity, where image will form. Okay. Position of image. Where image is formed here? Image is formed at F2. Image is formed at F2. Image means what? Where two or more refracted light rays will meet, at that point image will form. See, refracted ray 1, refracted ray 2, refracted ray 3. These three rays are meeting at this point, here image will form. Position of image is at F2. Okay. Yes. Size of the image. See, size of the image is highly diminished or point size. Image is looking like point size. We can even call diminished image also. We can even call diminished image also. Nature. What is the nature of image here? Since image is formed on right side of the lens, means real refracted rays are meeting. So this kind of image is called as real and inverted image. Real and inverted image. Students, you have to remember, if object is at left side and image forms on right side or other side of the lens, the image is called as real and inverted image. Suppose object is this side of the lens, image also forms on this side, then we can call that kind of image as virtual image. Okay? As our first case, object is at infinity place. These are light rays. Light ray 1, 2, 3. These three light rays moving towards convex lens. After refraction by convex lens, they are meeting at f2. So image of this object is formed at f2. What is the size of the object? Size of the image? Image is point size and are highly diminished. What about nature? The image is real and inverted in nature. Okay? Okay, students. Now we will study about image formation if object is placed beyond 2f1. Means beyond 2f1, this point is infinity. If object is placed between 2f1 is called center of curvature also. Between center of curvature and infinity, or else you can call beyond 2f1 also. Okay. If object is placed here, what is the position of image, size of the image, nature of the image, that we will study. Yes, to form the image, there must be minimum 2 light rays should pass through object. Yes, now I will draw the diagrams. See, first light ray after reaching the lens refracts and passes through focus because this is parallel to the principal axis. Light ray parallel to the principal axis after refraction passes through focus. Yes, this is the refracted ray, this is incident ray. And for simplification purpose, we will take another incident ray that passes through optical center. Light ray which passes through optical center remains undeviated. I told you people earlier only. This is the second incident ray. When it passes through optical center, it remains undeviated, means it does not bend at all. Yes. What do you mean by image? A point where minimum two refracted rays meet. Okay, yes. First refracted ray, second refracted ray are meeting at this point. So, image of this object is formed at this point. See, now we shall write position of object. Position of object is beyond 2f1. What is the position of image? See, image is formed between these 2 points. Which are those? f2 and 2f2. Image is formed. Position of image where between f2 and 2f2. Between f2 and 2f2. Okay. Size of the image. See, this is size of object. This is size of image. Compared to size of object, image is smaller or bigger than the object. See, image size, object size. So, size of the image is smaller than object. Smaller than object. While finding nature, I said you people, if real refracted rays means this is the refracted ray coming directly from the object. If real refracted rays meet, forms the real image. Or you can even use one more convention. Convention in the sense for our reference. If image is formed on other side of the lens, this is same side of the lens where we kept object. If image of this object is formed on other side of the lens, that image is called real and inverted image. See, object is on this side, image is formed on other side of the lens. So this image is called as real and inverted image. Okay, this is about image formation when we place object beyond 2f. Okay. Okay, students, our third case of convex lens image formation is when object at 2f2. 2f2 is a place that is also termed as center of curvature. Yes, I will take one convex lens. I will turn this as optical center. This is optical center. Okay. Focus called as f1. At the same distance of optical center and focus, we have to take center of curvature, which is also known as 2f2. Which is also known as 2f2, center of curvature. Yes. This side also. This is f2. When object is at 2f1. Sorry. This is 2f1, f2. This is 2f2. Yes. Shall we place object at 2f1 now? Shall we place object at 2f1 now? Yes. I am placing object at 2f1, exactly at 2f1. Okay. How many light rays we need to reproduce this object? Minimum 2 light rays. I will take first light ray which passes parallel to principal axis. After refraction, what happens? It passes through f2, that is focus. After refraction, it passes through focus. Yes. Incident ray after refraction passes through focus. Second, light ray passes through optical center. What happens? It remains undeviated. It remains undeviated. Light ray passes through optical center. Second light ray, this is passing through optical center. After refraction, it remains undeviated. See, what do you mean by image? Where two refracted rays meets, at that point image is formed. Image is formed here because these two light rays are meeting at this point. Yes. Okay. Which kind of image this is? Okay. Object is placed at 2f1. This position is 2f1. Shall we write position, size and nature of image? Yes. See students, where image is formed, this point is called 2f2. Where image is formed, position of image is at 2f2. At 2f2. Size of the image, object. Okay, both image and object are of same size. Size of the image is same as object. Same size as object. While finding nature, I said you people, if image is formed on other side of the lens, it is called as real and inverted image. This object is placed on this side, image is formed on other side. So nature of image is real and inverted image. Okay students, this thing you have to remember, when you place object at center of curvature or at 2f1, image is placed on same position on other side, that is at center of curvature only. 2f1 is called center of curvature 1. 2f2 is called as center of curvature 2 because a lens has two spherical surfaces. This surface has one center of curvature, this surface has another center of curvature. If you place object at center of curvature on one side, its image will form on exactly center of curvature on another side. And one more interesting factor is size of object, size of image, both are same. Okay? Yes. Okay students, our next case is when object is between 2f1 and f1. 2f1 is called center of curvature, f1 is called focus. If object is placed between center of curvature and focus, where its image will form, what is its size and nature, we will study now. Okay? I will draw one convex lens first. I will term them. This is optical center. Yes. Shall we take this as focus 1? Yes. At the same distance of optical center to focus, what we have? Center of curvature, that is called as 2f1. Yes. This is called as 2f1. Where we have to place object now? Between 2f1 and f1. This is 2f1, this is f1. Between these two I will place object. Yes, this is our object now. I placed an object here. We have to reproduce this object in the form of image. At the same distance we are focus 2. Yes, and at the same distance we are center of curvature. I have taken two rays. First ray, light ray passes parallel to principal axis. Yes, this is passing parallel to the principal axis. After refraction, it passes through focus. After refraction, it passes through focus. Yes, second light ray, I will take light ray passes through optical center. Light ray passes through optical center. Yes, light ray passes through optical center. After refraction, Light ray passes through optical center. After refraction, it remains undeviated. See. What do you mean by image? Image is a point where more than minimum two light rays after refraction. Refraction means bending. After refraction, where they will meet, that point is called as image of an object. See, these two light rays are meeting here, so its image will form here. Yes, object, image. Image is reproduced in inverted form. Object is in upward direction, image is in inverted direction. Shall we write its properties? Yes. Now tell me, what is the position of image here? We have to measure all the distances from optical center, focus, center of curvature or 2f2. Image is formed beyond 2f2. Image is formed beyond 2f2. Size of the image, it is clearly visible. This is size of the object. This is size of the image. Image is magnified, higher than object. Size of the image is magnified image. Or also you can write larger image. Magnified or enlarged. While measuring nature, I said you people, if image is formed on other side of the lens, it is called as real image. Real and inverted image. Nature is real and inverted image. Okay. This is the case when object is placed between 2f1 and f1. I mean center of curvature and focus. Between center of curvature and focus, image is formed beyond center of curvature or beyond 2f2, and nature is real and inverted, and size is enlarged or magnified. Okay students, now we will move to fifth case, that is when object is at f1 or focus. See, this is focus. At this point only I placed the object now. Okay? Yes. I will take two light rays. First light ray or incident ray is parallel to principal axis. We know very well, light ray passes parallel to principal axis. After refraction passes through focus. After refraction passes through focus. Yes. Another one. Light ray passes through optical center. Light ray passes through optical center. After refraction, it remains undeviated. I said you people, image will form at a point where two refracted rays meet. But these two reflected rays are not meeting here. But at certain distance, at infinite place, at infinity, they will meet. At infinity, they will meet. So, if we place object at focus, its image will be formed at infinity. And the size of the image is highly magnified. In concave mirror, you people may be familiar. Bike headlights or car headlights. Okay, now? Generally, lamp is the object. Lamp is placed at focus. Suppose this is bike mirror. If lamp is placed at focus, the light ray coming from the headlight of a car forms image of objects at infinite place. That is in case of mirror. Okay? Yes. We shall write position, size and nature of the image now. Where image is formed? At infinity. Image is formed at infinity. We don't know exactly. It will form at infinite place. Size of the image, highly magnified. Size of the image, highly magnified or highly enlarged also you can write. Nature, since it is formed on other side of the lens, this is real and inverted image. Okay students, these 5 cases we have reproduced this object in the form of image and all the images are real and inverted. Okay. Okay students, this is the last case where image is formed in case of convex lens. First 5 cases we have produced real and inverted image. Only in this case we will get virtual image. I will show you people. What is the position of object when object is between F1 and O? This is F1 focus. This is O, that is optical center. If I place object here, between F1 and O, yes, see, minimum 2 rays we have to take. This is first light ray, we call it as incident ray. The light ray which passes parallel to principal axis. After refraction, it passes through focus. Yes. After refraction, passes through focus. We will take one more. Light ray passes through optical center. After refraction, undeviated, it will move in straight path only. See, in previous case, when object is at focus, we obtain parallel rays. Parallel rays may meet at one point. But look here. These two are parallel or not parallel? See, these two light rays are not parallel. They are diverging light rays. As you move, they go on diverging. They will never meet. So, there is no chance of getting image by these two light rays on this side of the lens. Okay. If you extend them backwards, yes. See, if we extend them backwards, at one certain point they appears to meet. If you place the object here, its image is formed here. Okay now? Yes. Now we shall write position of image for this object position. Where image is formed? On same side of the lens. Where image is formed? On same side of the lens. Image is formed on same side of the lens. Okay. Size of the image. This is object. This is image. Size is enlarged. Image is enlarged. Enlarged image. Yes. In all previous cases, we obtain an image on right side of the lens or other side of the lens. If object placed here, its image is formed on this side. But in this case, we placed object here on same side of the lens only image is formed. This kind of image is called virtual image. But its actual definition is different. These two are real refracted rays. Means light rays refracted from object. But these two are not coming from the object. Object is here. These are refracted rays. But these are extended refracted rays. Extended refracted rays. If extended refracted rays appears to meet at one point, that kind of image is called virtual image. Nature of image is virtual and correct. Virtual, okay. Why erect here? If image is formed above the principal axis, this is principal axis, above the principal axis is called virtual image, below the principal axis, inverted image. Okay students, now we will study about formation of image by concave lens. Here we have only two cases. The first case is when object is at infinity. See, beyond 2f1, this point is called as infinity. I placed one object here which is infinite distance from concave lens. Now if object is at infinity, where does its image will form? We will show with the help of ray diagram. Yes, infinite means you should not draw thick lines at the beginning. Dash or dotted lines tells us these light rays are coming from infinite point. Yes. Please use dotted lines while drawing ray diagram for this case. Yes. While explaining types of lens, I said you people, what is diverging lens? Means this lens, when it receives parallel beam of light, it diverges those rays. Yes. After refraction, they are diverged. After refraction, they are diverged. See, parallel beam of light, refraction takes place at the lens. After refraction, they are diverging. Okay? Yes. See, these two divergent rays will never meet. To form image, either reflected rays may meet actually or they may appear like meeting. But if you extend them behind the lens, they appear like meeting at this point. This point is called as focus. Yes. The image is formed at focus. What is the position of image here? Image is formed at focus at f1. Size of the image. This is object. This is image. Image is reproduced as a point sized or highlight image. You can use any one. Point size or highlight image. What is the nature? I say you people. If image is formed on same side of the lens, this is virtual and erect image. Virtual and erect. Concave lens always produces virtual and erect image only. Okay. The second and last case of concave lens is here. That is, the position of object is between infinity and optical center. Anywhere, it may be at 2f1, it may be at f1, it may be here, anywhere between infinity and optical center. Yes, I placed the object here. See, I have taken two light rays. Light ray passes parallel to principal axis. After refraction, it diverges. Okay, one more. Light ray passes through optical center. Light ray passes through optical center. After refraction, it remains undeviated. This is a refracted ray. These two light rays are diverging. If we extend them backwards, yes, this refracted ray appears like meeting with this ray at this point. So image is formed here. Okay? This is object, this is image. Object and this is image. Okay. What is the position of image here? This is 2f1, this is f1. Image is formed between f1 and 2f1. Between f1 and 2f1. Size of the image. This is object, this is image. Image is smaller in size. Image is smaller in size. What about nature? Since image is formed on same side of the lens, so it is called as virtual and direct image. Okay. These are image formation by both convex lens as well as concave lens. Please practice ray diagrams. Okay. Thank you.